Okay, I think this is where we left off last time. This is the rules for how what C++ does if it finds an int on one side of an operand, of an arithmetic operand, and a double on the other side, or if it tries to do an assignment statement with a double on one side and an int on the other side. So rule number one, in an expression, an arithmetic expression, if one operand is an int and the other one is a double, it converts the int into a double, and the result of the expression will be a double. If it's an assignment statement, C++ will automatically convert the value of the expression on the right side of the assignment operator so that it matches the variable on the left side of the assignment operator. Any questions about that? Or should I just do a couple of examples? All right, I am working on loading up an example here. Give me a second. Okay, and I'm not sure, well, let me try that again. Many of you may have already looked at this because it's just copied from the lesson, so bear with me if this is repetitive, but I'm assuming there'll be at least a few of you out there for whom this will be useful. So here's some code, and what I'm going to do now is I'm going to stop and give you about 1 minute to figure out what you think the value of I is going to be when this program is done executing. I guess maybe I should say after this statement is executed, what will the value of I be? And what I'm going to do is I'm going to have you type that into chat, but I don't want you to type it into the chat yet. I want to wait 1 minute and give everyone a chance to think what they figure out what they think the answer is, and then I'll tell you when it's time to go ahead and type it in the chat. So 1 minute. All right, so if you have an answer and you want to type it in the chat, that would be fine. I want to keep working on it for a minute, that would be fine too. Okay, it's good. I appreciate those of you who are typing it into chat. It just kind of gives me an idea that people are actually out there, and sort of how many people are getting it. So let's go through it. Right now is when I wish I could use Excel, because then I could have an Excel cell for each of these variables and we could keep track of what's going on, but we'll just do it sort of informally for now, and I'll get Excel going for next time. So this first statement here, there is a conversion going on here, right? Because 11 is an int, X is a double. So what's happening here is that X is going to become equal to 11.0. And we actually use the 11.0 just to indicate to other humans that the value being stored in there is not an int, it's a double. Just to be clear, if you were to actually look in the memory location, the way that an int 11 is stored is completely different from the way that a double 11.0 is stored. So that's what we're trying to get at here by putting the 11.0 in there. We're saying, okay, that's a double, not an int. And then there's also a conversion going on here. right? The 4 is an int, so C++ needs to convert that int into a double before it assigns it to y. So y is getting assigned the value 4.0. And then on, I think I did the, anyway, on this last line now, we have x and y are of type float. So 11 divided by 4 is 2.75. But I is an int. So what's going to happen, we can't store a double value in an int variable. So we're going to convert that double into an int. And when C++ converts a double into an int, it just truncates it. It just chops off any decimal. There's no rounding, it's just chopping. So what's going to happen here is I is going to become 2, the integer 2. 2.75, when you convert 2.75 to an int, it becomes 2. All right, any questions about that? I know not everyone got that correct. That's okay, that's why we're doing this. Hopefully you got it now. Any questions? All right, let's do another example. All right, 1 minute to figure out what you think X is going to be after this statement is executed. Don't type it in the chat yet until I tell you to, please. Okay, go ahead. If you have an answer, type it in the chat for us. Okay, so we have 3 different responses so far, in case everyone's not watching. We have some 2.0s. We have some 2.75s. And it looks like we had a 2, but then the 2 got changed to a 2.0. So that's better. Okay, let's go through it and see what happens here. So when I say I gets 11, there's no conversion going on, right? That's just I is going to be the int 11. Same with J. J gets 4, no conversion. J is just going to be the int 4. So now I'm down to the last line. X gets I divided by J. The first thing I do is, before I can do any assignment, I have to evaluate the expression on the right side. Okay, I'm going to evaluate I divided by J. 11 divided by 4. In C++, when I divide 2 integers, the answer is always an integer. And there's no rounding, it just gets truncated. So this is 11 divided by 4 is 2. Any questions about why 11 divided by 4 is 2? Not 2.0, just the integer 2. Okay, so then I'm going to assign that 2 to a double variable. So I'm going to have to convert that int into a double. So it becomes, when I convert 2 into a double, it becomes 2.0. So what's getting assigned to X here is 2.0. X is going to be equal to 2.0. Okay. Any questions about that before we move on? Okay. So we have talked about integers and doubles. And basically what we're doing here is for each of these types that I'm going to talk about, you're going to see that I can declare variables of that type, and that means that those variables then will be able to hold literals or values of that type. So the next type we're going to talk about is a type called char. Char stands for, don't worry, don't stare at this example too much yet. We're going to get there in a minute, but for now, I just want you to look at this. Char stands for character. So a char variable is a variable that can store one character value. Python doesn't actually have anything like this, right? Python has strings, but strings can be used to store as many characters as you want. Can you go over the order? I'm not sure what you mean by the order. And I'm also not sure how long that was up there before I noticed it. Order of operations? I figured that. All right, I'm gonna go ahead, but Martin, if you want to clarify what you mean, I'm happy to.
Sorry. What I was trying to say was that in the previous example, it was an integer divided by an integer, right? And then that turned into, that was still supposed to be an integer, even if you stated before that x is doubled.
Right, because we had so we had x gets, basically it was 11 divided by 4, right?
Yeah.
So 11 divided by 4 is 2, period. We haven't even gotten to the x yet, right? We're just evaluating the expression on the right.
Okay.
And when we evaluate the expression on the right, the result is 2. So that's the first step, right? And then the next step is to assign that value to the variable x.
Okay, and then you double it.
Well, because in C++, if you've got an assignment statement with a variable of one type on the left and a value of a different type on the right, what C++ does is it converts this value on the right so that it matches the type of the variable, right? So it's going to convert the 2, it's going to convert the integer 2 into a double.
Okay. So it converts it into a double, and then it chops off the double.
No, it doesn't chop off the double. So
Okay.
when it converts 2, so the expression here evaluates to the integer 2, right? And then when I convert that 2 into a double, it becomes 2.0.
Okay.
And then what goes into x is that 2.0.
Oh, okay. That makes so much more sense.
Okay.
Sorry about that.
No problem. Glad we got that figured out. Cleared up. Okay. So in C++, we have two different types. We have strings and we have characters, type char. So strings can be any number of characters. Variables of type char can only be one character. You may wonder why we even need variables of type char. Why don't we just do strings for everything? The answer is we could, but this is just how C++ is, so we're going with it. So just like an integer variable, we could put an int value in it. A double variable, we could put a double value in it. Here, we've got a char variable, and we're going to put a char literal in that variable. In C++, the way that you indicate that something is a char literal is you put single quotes around it. So double quotes are for string literals. Single quotes are for char literals. And just to digress for a second, I want to make sure everyone's okay with the word literal. That's really just a fancy word for value, right? It just means when you see an actual value in your program, we call that a literal.
Question.
Hold on a second, I'm just looking at the chat. Would you lose points if you used a string for one character? I probably would not be that picky. Probably would be better practice to just use a char if it's always going to be one character. But I doubt very much if I would actually take points off or something like that. Not sure if you had a different question or if that was the same question.
I had a different question.
Okay.
So if I use double quotes around just X, it would be a string with a length of one character.
Correct.
So if I tried to use double quotes on line 8 there, I would get an error. Is that right?
Correct. Yeah. You would, because you'd be trying to assign a literal of type string to a variable of type char. And C++ has no way of making that conversion.
Got it.
So there's the red squiggly. Okay. I need to turn off that auto stuff. Okay, let me just see what else I want to say about characters here for a second.
Sorry, Professor, I have a quick question about characters.
Sure.
So you said that singular quotes for characters and then double quotes for strings. Can you use single quotes for strings? Like, are they interchangeable or not at all?
No.
Okay, cool.
Single quotes for characters, double quotes for strings. Okay, so just to talk a little more about how characters are stored in the computer's memory. What happens is, so a computer doesn't store characters. A computer stores numbers. So what we've done is we've come up with a code for each character, a numeric code for each character, and what gets stored is that code. So for example, the code for uppercase A is like, for example, if I, right here I said M gets uppercase A is 65. So if I were to actually look in the computer's memory and somehow be able to see what was being stored there in that memory location that is being used to store M, what would be in there would be the number 65. Okay. Let's see, what else do I see? I could show you, if you look at the lesson, there's actually a link to a table that shows you all of these codes. It's the ASCII table. But really, there's no need for you to ever know what the actual codes are. In fact, it's best if you don't. You would never want to actually use one in a program because that would make it awfully difficult for someone to read if they don't have the ASCII table memorized. So you just need to know that this is how it works. And the only other thing you need to know is just that all of the uppercase letters are contiguous. So for example, the ASCII code of uppercase B is one more than the ASCII code for uppercase A. Same thing for the lowercase letters. Same thing for the digits 0 through 9. They're all contiguous. They all have contiguous codes. So that may come in handy sometime in your program. So for example, that means that you could, if you wanted to print out the alphabet, you could say something like, we haven't studied loops yet, but maybe you can kind of guess at what's going on here. Okay, so I can actually you set the character variable equal to uppercase A, and then I can add one to it, and that just adds one to the code, so it becomes B. And then I add one to it again, and it becomes C, and I add one to it again, and it becomes D, and so on. So this for loop could be used to print out the alphabet. All right, if the fact that I used a for loop and we haven't studied that yet confused you, don't worry too much about it. You don't really need to understand that in detail right now. Okay, so let's get back to this example. I'm going to go through this example with you because it's, well, so if I had Excel up and running, what I would do is I would create a cell to put the value of, to put the variable M, and I would create a cell to represent the variable X. If I was in a classroom, I'd probably just draw squares on the whiteboard, put numbers, or put values inside the square. But anyway, so the variable M is going to have the character literal X inside. The variable X is going to have the character literal M inside. And then on the last line, basically what I do is I completely ignore anything else I did, and I just say see out the character literal X. So what's going to be printed on the screen is an X. So kind of a silly example, right? Because none of this up here actually makes any difference. I'm just printing out the character literal X. Everyone okay with that? No questions? Okay. Next question is, what if I, and let me give you just like 30 seconds or so again here to determine what you think your answer is to this question, and then I'll have you type it in the chat. By the way, we'll probably do this a lot, so I would highly recommend that when you come to class, quote unquote, come to class, you just have like some scratch paper next to you and a pencil so you can jot down some notes and figure some things out. But anyway, so the question is this, and don't type the answer in the chat till I tell you to, please. But what if I say this instead? What's the output of this program going to be? All right, so if you think you know the answer, feel free. All right, looks like it's unanimous. That's good, that is correct. So what's happening here is I'm putting the character literal X into the variable M, but that actually has no bearing on anything because all I'm doing next is putting the character literal M into the variable X and then printing it out. And so at this point, what's stored in X is the character literal M. Okay, one more example. And again, I'll give you, 30 seconds or something, and then I'll have you type it in the chat. What is the output of this program going to be? I'll let you know when you type. All right, if you think you have an answer, go ahead and type. All right, this is way too easy, obviously. Good, so, and I'm just gonna kind of beat this to death a little bit to make sure everyone's tracking with the details. So I'm going to go through line by line here. When I declare M, what is being stored in that variable? When I first declare it, okay, a char, that's true, but it's basically junk, right? We call it junk. We don't know what's in there. It's uninitialized. If I were to just say char M and then cout M, I would get some random character. Okay, so same with X. Okay, so now I'm
Question.
yeah, go ahead.
So what would happen if you try to print a variable whose value has not yet been assigned? Would it just give you an error?
No, it would give me a garbage value because it's whatever was just sitting there in that memory location before I decided to call that memory location M is still there. And so it would just print whatever that random value was. We can try it in a minute. Let me finish the example and then we'll actually try that so we can see it in action. Okay, so I want to execute line 8 now. When I say M gets X, what that does is it changes the value being stored in the variable M to the character literal X. Move X. So that's the result of line 8. Now, if I execute line 9 and I say the variable X gets the contents of the variable M, that just means that X is now going to get what? X, right? Okay. Any questions on that? So then when I say cout X, that means print out the value that is stored in the variable X, and the value being stored in the variable X is the character literal X. So it's going to print X. Any questions on any of that? All right, let's actually try this. In order to do this, I'm going to have to share my screen. Okay, so if I run this, I say debug, start without debugging. Oops, what did I do? Still there, but it's not giving me the M. Oh, the M. What? Oh, okay. So this is an interesting complication. Visual Studio has decided that it's not gonna let me do this, even though in standard C++, I should just get garbage. It kind of makes sense, right? Because it's never correct to print the value of a variable that hasn't been initialized. And so Visual Studio is just kind of trying to be helpful there. There's a setting somewhere in Visual Studio that would allow me to do it. Other compilers, it would allow me to do it, and we'd get to actually see what the value was that happened to be sitting there in that memory location before we ran the program. But Visual Studio won't let me do that, so we won't be able to do that experiment. But if I take that out, then I can at least get to see my X there, which is what we predicted the output would be. All right, any questions about all that? Okay, let me see what I want to do next here. Okay, so I'm done talking about characters. So we've talked about int, we've talked about double, we've talked about char. Let's talk a little bit about strings. There won't be any surprises here. It's basically the same deal. I declare a variable of type string, and then that means that I can store a string literal in that variable. I can print it out. I could also use a cn statement to read it in, whatever. Strings are a little different from the other types we've talked about so far, though. The int and double and char, those are all primitive types. Strings are actually objects in C++, so you can do a little more with them. You'll see that I have # include string here. In order to use strings, you have to put that at the top of your file. Unlike, you know, int and char and double are just built in. And then we'll talk in a little bit about a couple of special things that you can do because strings are objects. I just want to say a couple more things about strings first. One is you can have, so a string is 0 or more characters. That means you can actually have a string with 0 characters in it. So I could say, for example, let me say I'm going to start this off being equal to my dear Aunt Sally. And then later on in my program, I could say stir2 gets empty string, a string with no characters in it. Okay? And that just means, you know, I've got a double quote and then another double quote with no characters in between. Questions about that? Okay. You can use cn to read strings. The rule is a little surprising. If I say cout, enter your name, cn stir2, cout stir2. Let's actually watch this in action, okay? So there's the hello from this cout statement here, right? And then it's saying enter your name. I'm going to write my name. Whoops, I'm going to type. My name is Dave. And so what's going to come out, sorry, I just want to make sure we can see the program here. What's going to come out when I hit enter is my. Okay, so the way that the extraction operator works when the right operand is a string is it reads everything up to the next white space character, such as a space. So you cannot use the extraction operator to read a string that is more than one word, right? It'll only get the first word. And we'll talk about other options a little bit later, but not quite yet. All right, any questions so far? Okay, I want to show you a couple special things you can do with strings. Let me just get back to this. Okay, so you can actually use the plus operator on string variables and it will put them together, right? We call that concatenation. Not sure if you encountered that word in your Python class or not, but concatenation is just when we put two strings together. And so if I run this thing, it's going to say string 3 is hello there. Any questions about what just happened? Okay, so I will just point out one kind of tricky thing about using the plus operator with string operands, and that is that it only works if at least one of the operands is a string variable. Okay, so the other operand could be a string value, it could be a string variable, it could even be a character value or a character variable. As long as at least one of the operands is a string variable, you're okay. But if, for example, I tried to do something like stir3 gets hello plus there, it's not going to like that, okay? Because at least one of the operands must be a string variable. Okay, couple more things you can do with strings. Within C++, with primitive variables, you cannot put a dot after it, but with objects like strings, you can say things like dot, and then there are functions you can call on that string. So let's say, I'll just keep going with the same example. This. I could say cout stir3.length. Okay, length is just a function that you can call using a string object in front of it, and it returns the number of characters in the string. So what's going to get printed here? What number is going to get printed? Someone who's good at counting. Got 3 different answers so far. Okay, we have one changed. Right, so this string has 6 characters in it, HELLO space. This string has 6 characters in it, THERE exclamation point. And so altogether, it's going to be 12. Okay. Any questions about why it's 12? Okay, and then I just want to go over one more function that you can call on string objects. Let's say for 4. No, that's not. For 3. Everything I come up with is that. Anyway, okay, so this is going to print a substring of the original string. The original string was hello there. The way it works is the first argument tells us where to start the substring. So the first character in the substring is going to be the character at position 4 in the original string. Okay, so what character, so and when we're talking about positions in a string, we start counting at 0. So what character is at position 4 in stir3? That's right, the O, right? 0, 1, 2, 3, 4. Okay, and then here's where you need to be a little careful. A lot of students intuitively think that the 5 is going to show me what position the substring ends at. But in fact, that's not what the 5 means. The 5 means how many characters there are going to be in the substring. So that means start with the O and then take the first 5 characters starting with the O. So it's going to be O space T H E. That makes sense to everyone how we did that and what the 5 represents? So if I run this now, can you see that? Am I sharing? I'm not sharing my whole screen. Oh yeah, I am. Okay. So you guys can see the console window, right?
Yeah.
Okay, thank you. So any questions about why we got this output? Everyone's good on that. Okay, excellent. Okay, what I want to do now, I'm going to actually switch over and we're just going to kind of go through the lesson lecture notes for the next couple of sections. I want to take a detour and talk a little bit about programming style. I really have no idea what sort of stuff you talk about in your 115 class. So I'm just going to assume that you've never thought of this concept before and start from scratch. So the idea is that in the real world, when you're writing a computer program, it's almost never going to be done, right? It's not like you write a program and you say, okay, I'm done, and I put it on the bookshelf and I never look at the code again. It's always a work in progress. You're always debugging. Not necessarily you or someone is always debugging or improving or maintaining or updating or something. So it's really super important that the code is easy for human beings to read and understand. And so I've kind of come up with these 4 goals that we have. And in my experience so far anyway, everything that I can say about programming with style fits into one of these 4, or at least one of these 4. And they overlap quite a bit too, but we're going to go with this. We want to write our computer programs so that they are easy to read and understand, easy to modify, easy to debug, and easy to reuse parts. So that's the goal. So when you're writing your program, that's in the back of your mind somewhere. Right now, there's not that much that we've covered that we can do differently to make this easier, but I did come up with 4 ideas for how we can achieve these goals already, even before we get to if statements. Use good names for your variables. That's super important. Just think hard about what you want to call your variables and make them super descriptive. Use white space, blank lines, and also just spaces in your code, especially with blank lines. Use it to separate different parts of your program, so those are easy to identify. Use good indentation. We'll be talking a lot more about indentation. At this point, all we have is, if I can find a complete, I don't even have a complete program anymore in this lesson. Anyway, we'll be talking a lot more about indentation as we go. It becomes increasingly important. In Python, of course, you have to indent, right? The program won't work if you don't. In C++, the compiler doesn't care about your indentation, so it's up to you to use good indentation so that your code is easy to read and understand. And then finally, comments. In your code, you'll be writing comments to help someone understand your code. I go into a little bit of detail in the style conventions about what the expectations are. So make sure that you look there before you submit your assignment. Just as far as the technical side of things goes, like the how-to syntax, there are two ways to do a comment in C++. One is a multi-line comment, which means you start with a /* and then the compiler ignores everything it sees until it gets to a */. That's one kind of comment. The other kind of comment is a single line comment, which means anywhere in your code, you put a // and then the compiler ignores everything on that line after the // Okay. Any questions about any of these four items? Okay. Next thing I want to talk about is named constants. Really, this is just another, this should probably be item number 5 from the previous section. It's just another matter of good practice, good style, that leads towards these 4 goals, okay? And that is named constants. In Python, there's no such thing as a constant. So I'm not sure if your CS115 class, if you've used variables and treated them sort of like constants, or if you just didn't deal with the subject at all. But here's what I'm going to do. First, I'm going to show you the how-to syntax of making a named constant. And then I'm going to talk about why we would want to do that, okay? The way it works is, let's look at this code, and you'll see that there's this literal 12 in the code, all right? That's something you want to avoid. Not all the time, but most of the time, you don't want to have a numeric literal actually in your code. What we do instead is we give this literal a name so that someone can look at that and know what the 12 represents, right? So if I'm looking at this program and I see hours worked times 12, I may be thinking, okay, what's the 12 for? What's it doing there? But if I do it this way, so instead of 12, I put hourly pay rate there, then I can look at this code and immediately I know, oh, that's the hourly pay rate. That makes sense. So here's the syntax for it. You just put, it's exactly the same as a variable declaration, except you just put the word const in front of it. And the only difference that makes is it makes it so that that constant cannot be changed. Like if I tried to say hourly down here somewhere in May, and I said hourly pay rate gets 13, that would be a syntax error because hourly pay rate is a constant. The other thing to say is just that the convention, the very strong convention, is that we always use all uppercase letters for our constants, just so that it's easy to see that it's a constant. And then just notice that this declaration goes above into main. That just makes it so that we can access this thing anywhere in the file. All right, any questions about how that works? Okay, here's why we do it. Reason number 1, modifying our code is easier. Let's say, for example, we have a 10 million line program and the pay rate of 12 occurs 4,000 times in the program. Then let's say that we need to change the pay rate from 12 to 13. Well, what are we going to do? We're going to have to go through all 10 million lines of the program looking for the 12 so that we can change it to a 13. We can't use find and replace, right? Because there might be some 12s in the program that aren't the pay rate. The 12 is there for some other reason. So we can't just change all the 12s to 13s. So we're kind of stuck. All right. So using a constant solves this problem, because if we used a constant, and so all 4,000 times that the pay rate occurs in the code, instead of putting a 12 there, we actually use the word hourly pay rate. Then all we have to do is go to the top of our program, change this 12 to a 13, and we're done. Okay, so that's reason number one. Reason number two for using named constants is self-documenting code. Okay, so if someone's trying to understand our code, sees the number 12, it may be confusing what the role of that number is. Why is it there? What's it doing? But if you use the word hourly pay rate, then it's immediately clear exactly what's going on. Okay, any questions about that? There's some more information in the lesson, more details about it, which I would hope you'll have a chance to read at some point. I'm not going to go over the details right now. All right, so I'm about to completely change gears again. Just want to check and make sure there's no questions before I move on. Okay, I think it's still going to work best for us to just keep going through the lesson here. So I want to talk more about the stream extraction operator. So far, basically, we've just used it in a very simple way, right? We just have cin, extraction operator, and then some variable, and that means read something from the keyboard, put it into the variable. It's actually a lot more flexible than that. Let me just remind you that the action word here is, the action part of the statement is the extraction operator, right? Cin is not the command. Cin is an object or a variable that represents the keyboard. And so this is saying, this is an operator that says, take what's on the, take something from, extract something from this object on the left and put it into the variable on the right. Okay. All right, so here's some extraction operator rules. Rule number one, that's pretty much what I just said, right? Take one item from its left operand and put it into its right operand. Extraction operator rule number two. This is probably new, but the extraction operator always begins by skipping any leading white space in the input stream. So that it may not be clear why that matters or why that's important or what that'll look like at this point. So just kind of hang that on a hook in your brain for now, and we will come back to it. Rule number three, the extraction operator is always customized according to the type of its right operand. So there's actually a different extraction operator in C++ for each type that can go on the right side. And it does something different depending on what the type of the variable on the right side is. And so typically what it does is it's built so that it will read exactly one of whatever that type is and then stop. Okay, so if I'm using the extraction operator to read an int, it will read digits. And then when it first sees anything that's not a digit, whether that's a space or a new line or a semicolon or the letter Q or whatever, as soon as it sees something that is not a digit, it's going to stop because that can't be part of the int. Same with double. If it sees something that's not a digit, it's going to stop. The only difference is with a double could have a dot in it, and an int couldn't, right? So, that's the only difference. But basically, same idea. Keep going until you get to something that could not possibly be part of a double and then stop. I think I actually have these listed somewhere. Anyway, I'll stop. I kind of went off on a tangent there, so I'm going to stop and we're just going to go down the page here a little bit. Okay, here's a program that reads two integer values and puts them in the console window. Only new thing here is so far I've only had like one CN statement at a time. I've got two in a row here. And what I want to demonstrate is that if the user types 45 space 56, enter, what's going to happen is the first CN statement is going to read the 45 and then stop. So it's going to be sitting right after that 5. Then I get to my second CN statement. The first thing that's going to happen is like rule number 2 up there. I'm going to skip the leading white space. And then I'm going to read the 5, 6, and then I'm going to stop. Okay, so the result is going to be that 45 is going into num1, 56 is going into num2. Any questions about that? Okay. Additional detail number 1. Instead of putting and saying CN num1 and then CN num2, I could have just done it all in one line. And that's exactly the same thing. As far as the compiler is concerned, that's just 2 different ways of saying the same thing. And we already know this about cout, right? We've done this with the cout, so it shouldn't be too surprising, I don't think. Additional detail number 2, the new line character. Okay, so this is a little confusing and also very important. So you want to make sure you get this. But this is the same program up to this point, right? And then I just added 3 lines. But let's review. At this point in the program, if the user entered 45 space 56, enter, the extraction operator has read the 45 and the 56, but what is still left in the input stream at that point? If anything, is there anything still left in the input stream? All right, so either nobody knows or nobody's there. I'm going to assume that everyone's still there, but I need to explain this. White space, the space. Okay, good guesses. Let me explain what's going on. When the user types 4, 5 space 5, 6, and then hits enter, there are actually 6 characters going into the input stream. 4, 5 space 5, 6, and then a new line character. Okay. In C++, we can represent the new line character with \n. But what's going on here is that after this highlighted statement is executed, there is still that new line character sitting in the input stream. So when I say cout enter a string, and then I use getLine to read it, I need to explain getLine before this is going to make sense. So the getLine function is a different way of reading a string. So you can read a string using the extraction operator, but sometimes that doesn't do what we want it to do. So we can use getLine instead. And it's a function that reads everything up to the next new line character into a string. And so that's often very useful. But in this case, if I put getLine right here, what's it going to read into the myString variable? So what's left in the input stream is just the new line character and nothing else. The getLine function is a function that reads everything up to the next new line character. So in this particular case, what's going to happen is myString is going to get equal to the empty string because there's nothing before the new line character. Okay. And so what's going to happen, and obviously that's not what this programmer was intending, right? The programmer was intending that the user would enter something and that would be stored in this variable. But let me just actually show you this in action. Oh, I messed that up. All right, so what's going to happen is, well, let me just show you what's going to happen. Debug, start debugging. If I enter 4578 and I hit enter, you entered 45 and 78 and enter a string. The intention of this programmer was that it was going to stop and wait for the user to type something, but instead it just says you entered the empty string. Okay. Anybody want to try to ask a question about that? This is pretty important. So, you know, if you don't get it now within the next 5 minutes, hopefully you can take a look at this in the lesson and study it and maybe come back with a question on Wednesday if that doesn't do it for you. But let me show you how to fix it, okay? The problem here is that before we do this getLine, we want to get rid of that new line character that's still sitting there in the input string. Any ideas how I can do that?
Use the cn dot ignore, I believe.
Yep.
Yes. Function. Yes.
So if I say cn.ignore, that means ignore one character that's in the input stream. In this case, we happen to know that that one character that's sitting in the input stream is the new line character. So now if I run this again, enter two integers, 56, 78. Now it says enter a string. I can type a string and it'll say you entered hello. Everything works exactly as we had intended. Okay, so make sure that sometime between now and Wednesday, if it's not clear now, you figure out why it works with the cn.ignore there and why it didn't work before and what's going on with that. Feel free to ask a question right now if you would like to. Okay, so I'm going to stop there. There's a little bit left in the lesson, but I'm not going to actually take any more lecture time to talk about it. So I would encourage you to read this carefully. Can you use ignore for other things? Yes, ignore just means ignore whatever the next character is in the input stream, no matter what it is. So you may find a good use for that in assignment 1. You may have already, I think. But, okay, so on Wednesday, I think I'm going to dive into if statements and while loops. Just make sure you have take some time to go over this at the end of the lesson, and feel free to ask me some questions. The other thing is I don't know how many of you fit this criteria, but if you are one of those people that just really likes to see these things in video form as opposed to reading them, I got a little further into the lesson in the morning session, so I will try to post that in Canvas so that if you just want to watch the last 10 minutes of that, yeah, okay. All right, so I think I'm done. Any questions? Let me go ahead and stop recording.
Yes, I have a question.
Uh-huh.
I noticed how you put the cl.ignore right after you put cl for a specific input. And
Mhm.
then, yeah, but then on the example in the readings on the website, you
Mhm.
the coder for say put cl.ignore right above the get line. So my question is there like an order in which you have to do it for it to work well, or could you just
Well, the order definitely does matter. Like, I couldn't do it before doing the CN num2, but these two lines here aren't doing anything with the input stream, right? So whether I do the cn.ignore before the couts or after the couts doesn't really matter.
Okay, thank you.
Yep. Okay. If you don't see that recording there within like 24 hours, feel free to shoot me an email and remind me to post that recording. Otherwise, I will see you all on Wednesday.
Could I ask one question, please?
Sure.
How do we obtain the .cpp file to submit from the compiler?
Well, you don't retrieve it from the compiler. It's just a file sitting on your computer. So just browse to the file that's sitting on your computer.
Oh, okay.
That makes sense. And if you're not sure where it is exactly, you might have to use a find function or something, but you should be able to find it, right? You know what the name of the file is that you're looking for.
Okay.
Okay.
Yes, thank you.
All right. I will see you all on Wednesday.
I also have a question real quick, if that's okay.
Okay, sure, no problem.
Sorry. This is my first class here. Where do I submit the labs?
In Canvas, there's the assignment 1 submission link in Canvas in the week 1.
Okay, I'm one of the people who's stuck on the waiting list, so I don't have access to the Canvas.
Well, just wait until you do.
Alrighty.
And it won't be a problem.
Alrighty, thank you very much.
Okay.
Oh, and one more thing.
Yes.
On the Canvas page, there's no link to the Zoom for the lecture to get into here.
Right.
I went to the wrong room and then Kyle pointed me back to here.
Okay. My plan at this point, unless someone convinces me that it's a bad idea, is to just keep having our lectures here in this room. So you can just go to the syllabus and click on that office hours link.
Okay.
And I'll be here.
Got it. Thank you very much.
Okay. See you all on Wednesday.
Have a good day.
All right.